Assalamualaikum and very good morning. I am Siti Nadam Syamshir Ahmad with the metric number of CE170182. I'm going to present my final year project titled of Thermal Distribution on the Wafer Level Chip Scale Packaging WLCSP. Before I start this presentation, I would like to thank for my fellow panel, Dr. Wan Suzarina and also Dr. Farina. Also, I have very gratitude to my supervisor, Dr. Hasiza binti Hassan. This is introduction. The shortage of the IC packaging is very well known to the world and is very crucial. The demand of market need to be fulfilled. So, the outsourced semiconductor assemble testing or SAT are established to ensure the market demands are fulfilled. So, as we can see on the right side, is the graph that indicate the growth of market for IC packaging from the years of 2017 until 2021. The automotive market itself give a rising numbers of 20.5% other than other industry for the demanding for the IC packaging. As we know, to make the good IC packaging, there are a few factors that can affect the performance itself for the IC packaging. So IEC compliance have shows the guideline that a few factors that can affect for the IC packaging itself is material selections, adhesion promotion, bond integrity, and also the stress management. Besides that, we are well known the automotive market use the IC itself for a sensor. One of the popular sensor is LIDAR, also well known as light detections and range. Besides that, there are also ADAS, which known as the Advanced Driving Assistance System. Both of these sensor and systems using IC packaging. Scope of this project consists of design use, the size of 4mm x 4mm with a ball pitch of 1.0mm, and then the software used are ANSYS software that consists of steady state analysis and also transient analysis, while the parameters selected are for the head flow for 2 watt applies on the die surface, while the temperature selected will be in the range of -15 degrees Celsius, 25 degrees Celsius, 35 degrees Celsius, 45 degrees Celsius, and 125 degrees Celsius, 150 degrees Celsius, and 200 degrees Celsius. That was divided into 3 categories of first is cool condition, hot condition, and ambient condition. Next, for the objective for this project is first to develop the WCSP package using a copper and gold material. Second, to identify the limit of the temperature for the WCSP package, and third, to analyze the thermal distribution for the wire bonding using a copper or a gold material. All the project consists of thermal analysis. For the first project are related to the thermal distribution. For the thickness of the silicon are affected the value of the temperature rising 20 degrees Celsius, which is 50% faster than thickness. Okay, next is the reliability studies for 3D IC packaging based on the silicon interposer. These studies indicate the process and thermal cycling simulate as the thermal cycling range are in the between -14 degrees Celsius until 123 degrees Celsius. Then lastly is the solder ball reliability assessments of WCSP power cycling or the thermal cycling. These projects are discussed on the failures for the electro packaging and the effects to the reliability concerns of the IC. This project also shows the ATC are developed to the solder joint lesser than PC or power cycling. And for the chapter 3 methodology, this is the overall process. First, start with the engine data and then choose the steady state or transient. Then enter the geometry to design the WCSP. After that, we load design into the model, and if design have error, we need to check back our scale for design, and if no, we go to the setup. In the setup, we can load the material into the package that already load into the model, and then mass process are conducted, and if success, we can proceed with the solution process, and then if success, we can obtain the result. After that, we can repeat the program all over again, but now we can change the copper or gold material to be load into the package. After we load the design into the model, okay, we'll be able to see the design error. So if no, and then we can set up. This setup we'll be able to load the material into the package. So for this project, we can either choose the copper or the gold for our bond pad. Next, the meshing process happened, and if the meshing process success, we can directly use the solution process. But if no, we need to repeat. This
This is the steady state analysis. As you can see, there are three parameters that apply in this analysis. First, the heat flow are applied into the die surface. Second, the temperature are applied on the surface of die. And the third, the temperature also applied on the surface for the bond pack. This is the transient analysis. There are two parameters applied, which is heat flow on the surface of die and temperature on the surface of dielectric.
Okay, for a result in the cool condition for the steady state analysis, we can see both for negative 50 degrees Celsius apply to the surface indicate the maximum temperature for the both copper and gold material are getting into 22 degrees Celsius. While for 25 degrees Celsius applied to the copper and and also the gold material indicate that the rising of temperature is only in between 0.29 for a copper for a gold and a rising of 0.016 for a copper. Next, we're going to talk about the ambient temperature. In this ambient temperature, the temperature used are 35 degrees Celsius and also 45 degrees Celsius. We can see from this statistic analysis that the rising of temperature are slightly increasing. For gold is almost 0.125 degrees Celsius increasing, but for the copper itself is only 0.065 degrees Celsius. For 45 degrees Celsius that apply to the surface of the die, we can see the copper only arise at 0.119 degrees Celsius, while the gold still soaring up higher than the copper, which is 0.221 degrees Celsius. This is the operating temperature for the packaging suggested by the paper, which is 125 degrees Celsius. From this analysis, we can see the steady state thermal for the copper is only increasing for 0.53 degrees Celsius only, while the steady state analysis for the gold increasing quite significantly high, which is 0.99. Conditions. The last condition are hot conditions, and we can see from the hot condition there are two temperatures that apply, which is 150 degrees Celsius and also 200 degrees Celsius. Based on the result that obtained, we are able to see the copper only have a lower value of temperature rising, which is 0.66 for the copper at the temperature applied for 150 degrees Celsius, while the gold itself increased almost 1.23 degrees Celsius for the 150 temperature applied. And lastly, the highest temperature applied, which is 200, indicate that steady state for a copper rising for 0.92 degrees Celsius and gold still in the first place with 201.71 degrees Celsius. As we can see here, this is the graph for a steady state analysis that will include the copper versus gold. For the pink one is the copper, while for the orange one indicate the value of the gold. And as we can see, there are the gold value is higher than copper value, and especially for when we apply 200 degrees Celsius on the surface for the gold, we can see the highest temperature obtained is 201.71 degrees Celsius, and we can see for the both of maximum temperature at negative 50 degrees Celsius, both the copper and gold have the same maximum temperature. Next, for a transient analysis, we can see in the cool condition, even though we apply a lower temperature, which is negative 50 degrees Celsius, we can see the temperature rising in the package itself can soaring up into 98.548 for the gold, while for the copper itself, the temperature rising is almost 55.457 degrees Celsius. While for when we apply 25 degrees Celsius to the copper and the gold, we can see the temperature rising up more than 100 degrees Celsius. As for gold, is 173.55 degrees Celsius, while for the copper itself, show a significant high, which is 129.69 degrees Celsius. Next, we're going to talk about when we apply the ambient temperature to the transient analysis. And from this one, we apply for 35 degrees Celsius and also 45 degrees Celsius. When we apply 35 degrees Celsius on the copper, we can see the temperature rising for 139.58, while for the gold is 183.55. And even we apply for 45 degrees Celsius to the copper and gold, which is slightly high 10 degrees Celsius, we can see the temperature still rising quite high, which is 149.48, which is almost 10 degrees Celsius increase, while for the gold itself show also rising almost 10 degrees Celsius, which is 193.55 degrees Celsius. Next, this is the operating temperature for the
package based on the paper stated. Okay, we can see for 125 degrees Celsius on the copper indicate the higher temperature, which is 228.66. This indicate that the limit temperature for the copper in the transient analysis are 125 degrees Celsius. And for the gold itself, show the rising of temperature 273.55. For 125, they apply to the gold. Next, the whole temperature for a transient analysis. For the transient analysis, we'll be able to know that 150 degrees Celsius are applied to the copper and the gold. And the copper indicate the reading of 253.41 degrees Celsius for the highest, while for the gold shows a very high temperature, which is 298.55 degrees Celsius. While for the copper, for 200 degrees Celsius apply, we can see there is a very high temperature of 302.89 degrees Celsius. And lastly, for 200 degrees Celsius applied to the gold, the reading shows the 348.55 degrees Celsius are. Okay, then we can see this is the graph for transient analysis. From this graph, we can see from this reading that both of them temperature are increased, but the higher one is 348.55 when the gold material are applied with the temperature of 200. Next. Okay, discussion. Based on the paper, the 125 degrees Celsius are chosen as our operating temperature for the package. So for the steady state analysis, we can see that the gold show 125.99 degrees Celsius, and while for the copper, it show 125.53 degrees Celsius. While for the transient analysis, they show a very high temperature increasing, which is 273.55, while for the copper itself is almost 228.66 degrees Celsius, which indicate that the operating temperature for 125 degrees Celsius that apply give a good is very a big impact to the package itself. Okay, next, as we can see, the graph on the right side is the steady state analysis, and from this graph we can see that the temperature rising is quite linearly, while the transient analysis shows the increasing of temperature rapidly when the temperature applied is also increased. Okay, as we know, steady state analysis is the analysis that help to determine the initial condition for WCSP, because the steady state analysis are the analysis that has been undergo without any change in temperature, which is temperature is constant. While for the transition analysis, we can see that this will show or indicate the thresholds of temperature for the package itself, which is the highest value of temperature for the package able to withstand. So the transient analysis are the analysis that undergo the analysis with the variance of temperature, which is the temperature can be changed and can be higher and can be lower. This is the result for our thermal distribution. As you can see, this is the steady state analysis. You can see the flow of the red color is significantly rising from the dielectric and become red in the middle of this package. Why? This is the thermal distribution for transient analysis. As you know, we apply the temperature on the surface for the die. We can see the temperature is getting higher when the color changing into red. So the temperature that apply on the surface are getting red when the temperature is increasing. So from that, we can see that the transient analysis have a longer time before the package turns into a red color itself. The conclusion for this project, we can see that by replacing the copper material with this type of copper help to observe the change that may occur in the thermal distribution. The copper that we used for this experiment is Cu101100. But from this, beside that, we can also determine that the steady state analysis for copper and gold limited can be up to 100 degrees Celsius. However, for a transient analysis, the limit is 150 for a copper and 200 is 125 degrees Celsius for a copper, while 150 for a gold. This WCSP package are exposed to the temperature and the thermal distribution are be observed. For that, we can be able to determine the wire bonding failure and also predict what happens and reduce the causing of the wire bonding failure itself. Next, this is the recommendation that can be made to upgrade or to update this project. As we know, the version of NC software itself is not fully working software. So this is the student software. So there are a few changes that can be made, which is a Google geometry. In the geometry, we can have a slightly different in the measurement. Besides that, we can also improve the refinements of meshing. When we make refinements of meshing, we can able to determine the error that maybe happens
inside the package itself. So next is limited research on the new material that can cope with the replacements of the gold material itself to help improve the semiconductor industry. There are a few papers suggested that we use a silver and palladiums, but we can know that certain properties that they contain, such as for silver, which is high conductivity but lower in young modulus, can become causing for wire bonding to break easily. So the improvements of the material itself, it should be increasing to the industry. Next, to increase the speed of time duration for each analysis and to help shorten the time taken to test the package with different temperature. As we know, for a transient analysis will take a longer time when we apply a different temperature in a different time. So this analysis usually takes a lot of time before we can be able to see the result. So by shortening the time duration, we can able to save more time in analysis and finding the cost, which is also can use a different material for analysis. That's all for my presentation. Thank you.